Okay. Hi, Calgary. If you can hear me, let me know. Also, hi, Vancouver. How's it going? Hi. Let me just get my screen set up, and then we should be good to go once I've got confirmation from Calgary. Once I have, there we go. Oh, and I just need to change this boy. Hey, KV. Do you know how, if I'm on the right...
The way this works, it tricks everybody up. You don't actually use the
Oh,
you're on the right input, but the
okay,
just
gotcha.
switch over to the other one.
Perfect. Ah, I thought it was a
Now
button
it's
on there.
locked up for me.
Awesome, thank you.
Go before you. Oh, no, it's working. Okay.
Yeah, perfect. Thank you. Thanks. Oh, Kate is typing. Yay! Hi, Kate. Hi, Calgary. Okay. We are good to go. So, hi, everyone, Vancouver and Calgary. My name's Sadie. I haven't lectured you all before, so I'll just do a quick little introduction. I am a back-end developer. I work for a company that makes games to get kids active on playgrounds, like kind of Pokemon Go style. I'm also a Lighthouse alum, so you're in Tiny App Week. I remember Tiny App Week. It was really fun, right? How's it going? How is Tiny App? How are you finding it? Good? There's some smiles, that's good. That's awesome. I didn't hear any nervous laughter, which sometimes happens. Calgary, how's Tiny App going for you? Thumbs up, thumbs down? I'm gonna have Slack up here, and I'm gonna check it periodically, but if I miss anything, can I get a volunteer from Vancouver to watch the channel? You got it open? Awesome. Sweet, thank you. What was your name? Peter, awesome. Peter, so Calgary, Peter's gonna watch your Slack channel, so fire me any questions, and I'll check in with you from time to time as well. So, today we're talking about user authentication. And so you'll have started on this a little bit, getting cookies into your app. Is that right? Yesterday. We're going to talk a little bit about cookies, and then we're going to talk a little bit about encryption and hashing. And the first thing that I want to talk about is HTTP is stateless. And what does that mean? HTTP being stateless really means that it doesn't remember. The client and the server only get the information that is given to them. So when I send a request from the client, the server only gets the information that I'm giving it. It doesn't remember the request that I sent before, and it doesn't remember any information that I sent with the request before. And so it doesn't carry over any like user authentication. Can you zoom in? Yes, I can zoom in. Absolutely. How's that for you? So how can we remember information then if we're not doing it, if it's not being stored? Yes. Stored on the user's computer with cookies. Yeah, great answer. Score, 10 points. Yeah, so we can use cookies. That's one way. Let's start with the simplest implementation possible, though. Before we get into cookies, I want to start with like a really, like the simplest way of how I would pass information and keep that like in memory. And this can be as simple as the server giving you an ID, and for every request that you send back to the server, or every request you send back, the server knows who you are. So, or sorry, the client gives an ID, and then the server knows who you are based on that ID. So that's what we're talking about. We're just going like, every request I send, I'm giving you an ID, and then the server based on that ID knows who I am. So this is going to be first without cookies, and then we'll dive into cookies. So a couple other ways, you could add it to the body if you were doing like a post, or you could send it in the parameters. So if I had getcookies.com, I can add a parameter with my question mark. And let's say user ID equals 1. And then I can add as many parameters as I want. I can say name equals Sadie. And that way, this is being attached onto the requests getting sent to the server. So the server now knows that I have a user ID of 1 and my name is Sadie. You can pass in any information that you want in here. So let's make an app. Calgary, how we doing? Good. All right. I'm going to start up an Express server, an Express app. So this will look familiar to what we're doing in TinyApp. And we're going to, I'm just going to call it the Cookie Monster app, because why not? So I've just created my app.js, and that's where my server information is going to live. Oh no, I lost the screen. Thank you for letting me know. Back up. Nope. Come on. Oh my god. This thing is gonna kill me. Sorry, Calgary. Technical difficulties. Let me just... Okay, we're good. Cool, thank you. Let me know if that happens again. I think we have new ones of these, and I'm going to try and make sure that I use that for the next one. Okay, I've got my app. I want to use Express. What's the first thing I need to do? Install Express. Yeah. I'm also going to npm init-y. So now I got my package.json. Oh, man. Okay, we're good for now. I'm going to try not to touch anything on here. And npm install Express. I'm also going to install NodeMon. Have you been using NodeMon at all? Yeah, amazing, cool. Calgary, are you using NodeMon? because NodeMon's awesome. And it means I don't have to restart my server, which is fab. And now I need to require in Express. And initialize it. It's gone. Oh man. Okay, I'm gonna check and see if we have another. Oh my god. Stay. Okay, we're good for now. All right. Okay, so we got Express. We got it Express in our app, and I'm gonna add a listener. We're gonna go port 3000, and I'm just gonna console.log listening on port 3000. Okay, so now when I run nodemon.js, it crashes. What did I do wrong? I didn't call Express as a function. And I also spelled port wrong. Fair enough. Cool. Now we got listening on port 3000. And it's gone. Oh my god. Okay, hang on 2 seconds. No. Okay, no, the new one is in the other room. We're just gonna be real careful with the TV. Okay. So what I'm intending to do is pass in my user ID parameters and verify that against a user database. So I'm going to create a little user database here. User DB. And I want to have the ID be a key, first of all. So I need to do ID1, username, echo. And we're just going to store some information. Favorite cookie is chocolate. Echo's my cat's name. I don't think she likes chocolate cookies, but oh man. Okay, it's back. It's like every time I look at it over here, it just pops back up. I don't know what I can do to make that stuff happening. USB-C. Oh, do you have another one? Oh, man. Amazing. Thank you so much. Well, I hope so. Oh, thank you. Good so far? No? There we go. Okay. Thank you so much. It's probably, yeah. But it's working now, so we'll just like not touch anything and hope it continues. Calgary, awesome. NodeMon, sweet. Okay. Okay, so we're making database of users. We've got Echo, which happens to be my cat. We'll do another user and ID equals 2. Does anyone have a pet's name they want to volunteer? Sorry? Ozzy. Awesome. Is that O-Z-Z-Y? Ozzy. Aww. What kind of pet is that? A what? A Morkie. What's that? A Maltese and a Yorkie. That's so cute. Aww. Apparently he didn't turn out that way for Calgary. Oh yeah, that happens. When we got my dog when I was a kid, she was a Rottweiler German Shepherd Lab, and the vet was like, yeah, she'll be like 60 pounds and a good running dog. And we had like a small house, 100 pounds. She was like this giant beast of a dog, but very cute. Okay, what's Ozzy's favorite cookie? Milk bones? Cool. And we need one more. Calgary, give me a pet's name. Kate's typing. Leela. Oh, that's a really sweet name. And who is Leela? What kind of pet is Leela? And what is Leela's favorite cookie as well? Cat, sweet. Mice. Mice/chicken, awesome. We're gonna say mice chicken, because we can just make cookies out of whatever we want. And so it's a mice chicken cookie. Okay, we got our user database, and we're gonna create a route for the route now. Yeah, is it? Sorry, fave cookie. Thank you for spotting that. I just want to write fave, and for some reason my developer brain is going, no, make it shorter, write FAV. Whatever. Okay, I want a route now, and I'm gonna say app.get for the route, and rec and res. Get our arrow functions going. So now what I want to do, I want to verify this user database based on this ID. So based on this guy here, I want to just say like, yeah, I know, like I've got that in my database. That's fine. You can access this. It's cool. So I'm going to say const user ID equals rec.query.user ID. So this is a bit different from params, which you'll have been working with before. Params are what gets sent if I had like ID here. But because I'm using the query itself, this is what gets sent when I've got a question mark. And then anything in here. So rec.query.user ID should give me the user ID. And to actually check if it's in my database, I'm going to say const user DB and user ID. And then for now, let's just print that back to the screen so I can see, I just want to see that user's information. So I'm going to say res.json and user. And res.json is really helpful when you're dealing with Express. I mean, you can use a console log as well to get the information, but res.json just takes an object and prints it to your screen, which is nice. So now, when I go over to localhost, I've got localhost 3000. You'll notice in my search history, I've got counting cows. This is for the lecture you had yesterday, which was on CRUD with Express. I do a cow tracking app for that. Just for fun, trivia. So 3000, and I'm going to enter in my parameter, and that is going to be user ID, as I've specified that already. And that is going to be 1. Cool. So I'm getting back the information here. So I've technically verified a user in here. I can pass in a different ID. We get Aussie. And if I pass in 3, we have Leela. Cool. So the way this would work is now, if I wanted to keep track of a user on every request I send, I could, in theory, add this parameter into every URL that I send. That doesn't feel great, does it? That feels kind of messy, and that's going to really kind of bog up my URLs. Like adding a user ID onto every single request I make is not an efficient way of writing code. Not super secure either. This is visible now. So let's say I go to a site, I go to fave cookie user ID, and my user ID happens to be like 5. And I copy the link and I send it to my friend. And I'm like, oh, hey, this is a really cool link. And they paste it in. Now they're logged in as me because they have the user ID in the string, right? So really not a great idea. So let's not do that. But this is kind of the simplest implementation possible of sending that information back and forth. It makes the URL bad, but it is a way of sending information. And essentially, it's the exact same way that cookies work. So it just means that we don't have to mess around with our URLs with cookies, basically. So before we move on to cookies, any questions so far on any of that? No? Calgary, how you doing? Questions? Comments? I will just give a second. Cool. I'm gonna head on to cookies then. So we are going to create a login form, as all good web pages have, so that we can verify our users instead of just like passing in an ID. I'm gonna remove this for now, but I'll paste it into the notes for reference. Cool. Okay, so we got, yeah, user ID. Let's flip back into app and close that up. So we'll take this out, and we're going to create a form. To do that, we need a bit of an interface to look at, and we're going to create this form with EJS. So as you're using with Tiny App, we're just going to npm install EJS. And now to use EJS, what do I need to do? Set the view engine. This is just the EJS thing that you got to do. And set it to EJS. Okay. And we're just going to render an index for now. So res.render index. And now we got to create an index page. So where do all your EJS files live? What folder do they live in? Views, yeah. So I'm going to create a views folder. And I'm going to create an index.ejs. Okay, so now, okay, I'm going to add my HTML boilerplate. Did you know in VS Code, you can type ! enter, and get your HTML boilerplate. You can also do, I don't actually know I haven't looked at the difference. I usually do HTML5. I think it might be the exact same thing. But that's nice boilerplate. That is an extension you can install into Sublime called Emmet, if it's not already like baked into Sublime, and it's just really useful. They've got some great HTML shortcuts. In addition to that, actually, so we'll do, what have I done? I'm gonna do, this is just not HE, H2. We're gonna make a login, and I'm gonna do form. Oh, it's not gonna do it. Hang on, form. Yeah, so I can just type in form without the brackets, and I get the Emmet abbreviation. It asks me if I want to do a get or a post, which is kind of nice. So I can just select post, and it gives me like the boilerplate for that, which is kind of cool. Sorry? I believe so. If not, believe it is default for VS Code. Sorry, for Calgary, the question was, does Emmet come on VS Code by default? I think so. If not, it's really easy to install any packages for VS Code. You can just type in Emmet. So, you think it does? Yeah, I don't remember installing it, and it doesn't look like there's a package. So, yeah. And I don't think it is in Sublime by default, though. I think you have to install that. But yeah, so that's handy. Okay, let's make a form action, and we're going to make this to a login page. We're going to make the post to the route login. Sorry, not the login page. And we'll add our inputs into here. So I'm going to go input, type. Text, not test, text. And username. And then I'm going to have password. Does anyone know what happens by me telling it is the type password? What does that do? Sorry, say that again? Yeah. It doesn't show the characters, so when you type in, you get those little dots. That's what type password does. It just goes, yeah, we don't want to show people this. Name, password. And it's going to be a submit. Cool. Okay, so we've got a form template. Now, we also need body parser to be able to parse the body coming in. So we're going to npm install body parser. And up at the top where I'm doing all my requires, body parser. And then to use body parser, what I need to do is add app.use. And this just means, what this does is just say, like, take my form data and put it into a format I can read. Cool. So in our post route now, we need to create a post route. So we've got our get route, which is serving up our index, and now we need to deal with what happens when someone submits that form. App.post to login. Rec.res. And I'm just going to grab the username and assign it a variable. So the rec.body.username. And, oh, no, why? Okay, sometimes the autocompletes can be a little annoying in VS Code. So we got our username, and we also want the password. Okay. And let's just console log that for now. Oh my God, stop. And see what we get back. So, oh, we need to add some passwords in, because we don't have that in our database yet. So password, we're gonna go meow. What's Ozzy's password? Crikey. Love it. Awesome. Calgary, Kate, what's Leela's password? Give me a sec. Dun, dun, dun. No. Cool. No password. I'll add that in. Awesome. Okay, so let's console log that in. We'll try to log in using the information that we've already got. And actually, I'm going to do a res.json instead of... yeah, I'm gonna do res.json just so I can see on the page. And to use res.json, I just need to wrap everything in an object so it knows that it's like an object. Otherwise, it's just going to grab those strings. So now when we go to our page, dun, 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 cannot find module EJS. Awesome. Why not? Did I maybe not install that? Let's try that again. Whoop. Oh, sweet. My VS Code's gonna freeze on me. Okay, bear with me for 1 second, and let's see if we can get this up and running. Yeah. It does this a lot. Yeah. It's all good. Okay. It just needed a little refresh. It's fine. Okay, let's npm install EJS. Okay, not in there. So what I did there was not install it in my actual package. I've installed it in like the whole root. So I don't want to do that. I'm gonna delete and delete and cd into Cookie Monster. Install EJS. Now let's see if we can get it going. Woo! Yay! Oh, this is my the company I work for is called Biba, and we have like a test login account, and so it's obviously just stored as like a password. We're not going to use that because that is not a user in our database. We are going to use we're going to go echo with the password meow. Cool. Save. Okay, no, I don't want to save the password. So we're verifying that user. We're getting in the rec.body, we're getting username echo, we're getting password meow, and we're hopping into this post, grabbing, creating a variable with the username and password, creating a variable and just returning it. So we're not actually verifying yet. We're just returning like the information given to us, the username and meow. We need to still do that verification. We need to check that it's actually a user in our database. Because right now this is just like a random string. We need to validate it. So we can do that by looping through our user database. We're going to say let logged in user equal null for now. I want to return like the object of the logged in user. So I'm going to create that as a variable to start with. And for user ID in user database, I'm going to set const user equals user db user ID, just so that I can use that user object a little more easily. Again. And let's say if the user, so this is the user in our database, if the user.username equals username, and we'll do the password validation in here as well, and user.password equals password, then logged in user equals user. And we'll just put out a break here so that breaks out. And instead of username password, what do I want to return? Logged in user. Yeah, cool. So we've got our validation in here now. And yeah, let's just check that out for now. Okay, awesome. Okay, I'll just save it. So we have our logged in user, and we're grabbing from the database ID, username, favorite cookie, and the password. So this is our validation in practice. Okay, so I'm signing in as Echo, but this is where, actually, first let's redirect to the home page on login. So instead of res.json, I want to redirect to home. So now I log in, but what's happening here? Let's have a look at the network tab. So I'm at my home page and I submit, and I've got a login request here. So if I scroll all the way down, I get the form data, and I can see like this login request is working. This post is working. But then I have a redirect to localhost. And so there are two requests being sent. The first one is this post, and then the second one is this redirect. The redirect doesn't know that I'm logged in. And this is where the stateless nature of HTTP comes in. So it has no idea that I've just logged in, which is why I'm just presented with the login screen again. So how do we solve that? Cookies! Yeah? Were you going to say cookies? Sorry. You can just shout out. Don't worry about raising your hand. Okay, so cookies. So first things first, let's install our cookie parser. You've been using cookie parser so far in TinyApp? Awesome. npm install cookie parser. And we're going to require cookie parser. And then to use it, we've got app.use cookie parser, and it is used as a function. So when we first make a request, there aren't any cookies involved. But when I log in, I want some information to be created, and then I want every subsequent request to remember that information, and basically like have it stored somewhere so that it gets sent along with every other request. When I use cookies, the server creates a cookie and sends it to the browser, and the browser stores it and uses it every time it makes the request. So where do we create the cookie? Like, where in here would we create the cookie? Really, like after the validation, right? We don't want to create a cookie before we've verified this user. We want to create it after we've validated them. So first, let's check if the user is logged in. I'm going to say, so if the user is not logged in, then I just want to send not logged in, and we'll return that. And I should really be sending like a status code along with this. You'll have that in TinyApp, but for now I'm just going to send like not logged in. So if I type in a garbage password, I'm going to get not logged in. Cool. So that's handled, which is nice. And now I want to create a cookie. And I do that with res.cookie. And then my first parameter is just the name of the cookie that I want to create, which is going to be user ID. And we're going to give it the logged in, not in strings, because it's a variable. Oh my God, stop. You'll notice with my code, and I'm pointing this out because this is not good practice, I flip between like double quotes and single quotes a little bit. I would strongly advise not doing that. Pick one and stick with it. I work in a language where like exclusively we use double quotes and single quotes are not allowed. But for JavaScript, I think single quotes look better. And so I just naturally flip between the two. So bad, don't do that. Calgary, how you doing? Good so far? Any questions? Any questions from Vancouver? Cool, cool, cool. Dun, dun, dun. Right. Christian's typing. No, all good. Awesome. Thanks, Christian. Okay. So I'm naming my cookie, and I'm sending it the logged in user .id. So this is going to be my new cookie. I could, if I wanted, just send it the whole logged in user. Like I could give it the entire object, but like really with cookies, you want to give it as little information as possible. You don't want to send the whole thing. You just want to give it like that ID that you need. The littlest amount you need for the purpose that you are using it. Cool. So now when I hit redirect, the cookie should be attached onto it. So let's have a look. Go into our application, and we've got our cookies here for localhost. Yeah, we've got some cookies. Okay, so now when I log in with meow, awesome. I'm getting redirected, but my cookie is getting stored. So I have user ID with a value of 1. So I am storing a cookie, but I'm not really using it for anything yet. So what we want to do is when we make the request to the home page, we want to check if there are any cookies stored and then use that as like validation of, hey, this person is logged in. We want to check if there are cookies. So when we go to the home page, so back up here, let's just console.log rec.cookies. And this is going to tell me if there are any cookies, and it's going to return them back to me. So now if I log in, I know I've got the cookie, and there we go. I've got cookie here. User ID is 1. Let's test what happens if I give it the wrong password. Cool, not logged in, and as we can see, we don't have any cookies stored here. So that's exactly what I want. I don't want to store cookies if I'm not logged in, because that would be bad. So we are making a post request to the server. The server responds with a cookie, and that cookie gets attached to every other request that we send for as long as that cookie is like alive, as long as that cookie is there. Okay, now what we want to do, let's send our user to our EJS template. And so in app.get, let's say const user ID equals rec.cookies.user ID. And I'm going to pass this in as a user object. And so to get the user itself, user DB with the key of user ID. Okay, so now in my EJS, I should have access to this user object, which should be the user that I've just logged in as. So if we wanted to render, let's say we want to render a message on the home page, on the login page instead of the login form. So if I'm logged in, I don't want to see the login form, right? we're going to use our if. Oh, good spot. Where was that? Thank you. Is it Gergely? If I'm getting that wrong, I'm sorry. Please tell me. But thank you. Good spot. Excellent debugging. Cool. That would have errored out. Whoop. Awesome. Okay, so in theory now this should work. Let's go ahead and create our if statement. And so in EJS, that looks like if user. How have you found working with EJS so far with like this funky code? Annoying. Harder. Yeah, definitely. So harder to deal with syntax errors and easy to make mistakes with that. I totally agree. I find it a bit disorienting going from like JavaScript to EJS. I'm like, oh my gosh, where do I put this like percentage and this bracket? But it's good practice. Okay, so if we have a user that's in theory logged in, h2 hello. And we're just going to add in the user here. And what's the difference? I'm going to throw this to Calgary. Question for Calgary. What's the difference between where I've got if here and my EJS like tag? I only have a percentage sign, whereas here I have percentage equals. Can you tell me what the difference between the two is? Awesome, 10 points to Kate. The equals means it's going to show it. So the equals sign says, hey, print this to the page. Whereas this is just going, no, this is code. Like, we don't need to show this, it's just code. So we got hello user.username. And let's add the favorite cookies. And we're going to go user.favecookie. And h3. Okay, so if user, we're going to give a little hello message. Otherwise, or else, we are going to have our login form. So I'm going to just move my h2 down and add our ending bracket. Cool. So that kind of messes up my syntax highlighter a bit, but I think that should be all good. Let's have a look at what happens when we log in. We're gonna log in as Aussie. Okay, so something's gone wrong. We are still storing the cookie. Awesome. But we're not getting our message back to say, like, this is the user that's logged in. So let's have a look at our code. This is where we do our, like, detective work. Say that again? Oh, excellent point. Rec.cookie. Thank you. So we had an S in there, but it should be request. Let's try that. Dun, dun, dun. Okay. Rec.cookies. There's some good debugging going on here. Dun, dun, dun. Okay, so the cookies, first off, it's rec.cookies, so cookies plural. You can't just have cookie, and the cookies actually come into the request. not the response. So because they're incoming as like, hey, this user ID is attached to this request. So we get the request in. Let's try that. Da-da-da. Let's restart and try deleting cookies. So if I delete my cookies and I go back, we get the login page. We can log in as Aussie and submit. So we get Hello Aussie and we get Milk Bones. Okay. Yay. So if we want to log out now, what we would need to do is delete the cookie. So essentially, we have now solved statelessness in HTTP, right? Solved. We're done. It's the end of lecture. Any questions so far on any of that? Great question. So we've got all of these. So the question for Calgary is we've got all these other columns. Is this page you're talking about? We've got all these other columns that give us some information. We've got this HTTP. Let's check out what happens in these when I make the request. I'm going to have to delete my cookie first. Okay, so we got echo and meow and submit. Nothing really happens in HTTP. We are getting the domain and the path expires. So if I'd set my cookie to have an expiry, that would come up here. I'm not sure what is supposed to show up in HTTP. That's a good shout. KV, do you know? So maybe HTTPS instead of HTTP? Yeah, I'm not sure. Yeah, something I've never encountered when dealing with cookies. But yeah, you do get a bit of extra information here, which is nice in the cookie. So Calgary, any questions so far? Just give a minute for Calgary. So we have cookies and we are storing user information. No questions? Awesome. Thanks, Christian. What's the security vulnerability about doing this? Passwords are plain text, so that's one. Yeah, I mean, that's a big no-no. What about this information here? It's visible. I can see it. So I can see user ID 1, which ultimately, like, this is only really on my computer. It's like if someone comes over and physically steals my laptop off of me, then they can see my cookies and they'll be able to see my user ID. But still, it's accessible. And really, the security vulnerability here is that if I have something like a user ID, which is potentially like guessable, so let's say I'm a hacker and I log in and I've got a user ID of 1. I'm like, sweet, I'm gonna just try and type in 2. Let's see what happens. So, is that gonna work? No. My Chrome like cookie changer is not working right now, but what would happen and what you can make happen, I think, with a browser extension or when DevTools are playing ball, is this would just flip into the user with the ID of 2. So if I have an ID that is predictable, I can just change it to something else, and automatically I've got access to other people's information. Let me just see. Where are we at? Okay, now I think, yeah, now's a good time for a quick break. Oh, actually, before that, I'll just talk really quickly about encryption. So when we're using our cookies right now, it's just plain text. And so we know, like, the back of our heads, we know that plain text, probably not great. And so for Tiny App, what you'll be using, if you haven't already, you'll start with cookie parser and then change to cookie session. And what's the difference between cookie parser and cookie session? Cookie session lets us encrypt. And so these are encrypted cookies. And generally, as a rule of thumb, if you are using cookies, you should absolutely encrypt them. Encryption would turn my password of pass1234 into something that looks like this. Or maybe not, maybe something different. And that way, A, it's not super guessable, and B, it's not plain text. So basically what you'll be doing in Tiny App, you're removing cookie parser and replacing it with a cookie session so that you have an encrypted cookie. Generally, you wouldn't use cookie parser, but some reasons that you might are for, I guess I want to say trivial, but they're not trivial. Things like storing shopping cart information on a web page. That's when you would use cookies, and like you can use plain text for that. It's not super important. Or for storing like the default language as well. That's another place that you could use just plain old cookies, but not for passwords. Never for passwords. Cool. We're going to take a 15-minute break now, unless there's any questions from Vancouver or Calgary. Otherwise, let's meet up back at 10:15. Sound good? Awesome. Thanks, Christian. See you in 15. All right. Hey, Calgary. Can I get a high five if you're ready to go and can hear and see me? Vancouver, I see you, so I'm assuming you're all good. Hey, awesome. Thank you. Okay. So it's time to name and shame. Hands up. Who is currently storing their passwords in plain text? Everyone put your hands up. Right. Which is fine, because Compass told you to do it. Greg, you most definitely are. You are, Greg. And like I said, we told you to do that, so I'll forgive you on this occasion, and this is the only time that you're going to do this. And you're never going to store passwords in plain text ever again, right? Right? Yes. Okay. Why? Why should we not store passwords in plain text? Security. Yeah. Who has, okay, let's say we're storing passwords in plain text and we got to store them somewhere for verification. So we're storing them in a database. Who has access to that database? The developers that have access to that repo, anyone on the behind the scenes of the company's website, administrators that have the administrator password, any hacker ever has access to those passwords because they are stored in plain text. If they are stored in something different, then we can make them essentially useless to hackers. If they are stored as something other than plain text. So let's talk about encryption. Encryption is basically an algorithm that modifies an input. Whoop, I can't spell modifies. An input into a different output. So, like we saw here, we get a password, nice simple plain text password, and we turn it into some garbage. Once you've encrypted something, can you decrypt it? Sure, if you know the algorithm, you can decrypt it. So given an algorithm, or given the algorithm, you can decrypt. So that's encryption. What's hashing? Yeah, Peter? Yeah, go for it. Mm-hmm. Great answer from Peter. So for Calgary, it's a way of like we're still modifying that input to a different output, but changing slightly. So if you change something ever so slightly, you're changing the pattern of it, and that changed the hashing, which essentially is also the way encryption works. The difference with hashing is that you can't decrypt it, and this is so. You hash something, you can't then use that hash to get your information back. And that's the main difference that we're working with here. Calgary's good. Bearing that in mind, which one of these do you think we should use for passwords? Hashing. Yeah, we should probably use hashing for passwords. Now, if we were to use encryption, we could get the password back. Do we ever need access to this password? No, not really. Really, the main goal of your app should be, I mean, not the main goal, but what you should be doing with passwords, you get them in as plain text, and as soon as you possibly can, turn them into something else and never worry about them again. You never need that plain text password because you can use there are ways to use that hashed password to verify. You don't need that plain text. So you're kind of better off never knowing what that plain text password is, ever. Facebook, I'm looking at you. Facebook had has everyone seen that, where they got like some historical passwords stored as plain text, and everyone was like, seriously, guys? Seriously? Your Facebook and you're storing passwords as plain text? When I was in boot camp, there was a tech job board that I signed up for. I don't know if it was BC. I don't want to name and shame. I can't remember what it was for, but I signed up for it and I got the verification email. And in the email, it had my username and password. I was like, you're a tech job board and you're sending me via email my password? Get out. So it's bad, but companies still do it, which kind of sucks. Anyway, tangent aside, if someone somehow got access to a hashed password, there is very little that they can do with that. If they got access to, let's say I've hashed one of my passwords in the app, and I'm a hacker, I got access to it. I can't just enter in that hash password because that's not going to log me in. I would need access to the algorithm that hashed it to be able to compare the two. Which brings me to salt. So let's talk about salt. What is salt? Calgary, what is salt? Apart from like tasty stuff that you sprinkle on food. Calgary, I don't see any typing. What's going on? Are you with me? 5 seconds. 5 seconds! Okay. That's okay. I'll just tell you what salt is. Salt is, I mean, you can essentially think of it as like sprinkling stuff on. We're just sprinkling data on our passwords. Salt is random data attached to the password when it's hashed. So in theory, even if you could hack the algorithm, if you don't have the salt, you're never going to get the password because you don't have those random little bits of data that have been sprinkled into our password. There's lots of different hashing algorithms. We're going to use bcrypt, and that's what you'll be using in TinyApp. It's a very good algorithm. There is a really good reading in Compass. I believe that's today, if you haven't already done it, on different hashing algorithms. And bcrypt is a very good standard. So we are going to use that. Bcrypt. Bcrypt. Is Bcrypt secure? Let's go to the Wikipedia page. Bcrypt is a password hashing function. There's some information here if you wanted to read up the Wikipedia page. Besides incorporating a salt, it's adapted over force. It is very resistant to brute force search attacks. And so by brute force, I mean a hacker that just goes and writes like an algorithm for, oh, if I type in 1, 2, 3, nope, okay, 1, 2, 3, 4, nope, okay, 1, 2, 3, 4, 5. And that's like a brute force attack. You can get some background on it, description, versions. There is lots of information about these algorithms. You get the setup and everything. So, lucky for us, we have an npm, if I could spell, we have a bcrypt npm package. And we are going to install this into our app. So what I'm going to do, I'm actually just going to create, I'm not going to do this in our app. I'm going to create just a hashing.js file, not in Cookie Monster. And in here, actually, I am going to put that in there because that's where my node modules are. Because I need to npm install bcrypt. Not jbcrypt, just bcrypt. And essentially the first thing we're going to do is copy over the majority of this documentation. Bcrypt is like, their documentation is really good. It gives you pretty much exactly what you need. We're going to go down to, do we have that? No, not yet. Cool. So we're just gonna copy this. So we got const bcrypt, got salt rounds, which we'll talk about in a minute. I have a plain text password and then some other plain text password. And I'm actually going to change this. I think in the initial like demo of this, or like the initial documentation, this is supposed to be bacon, and then this is not bacon. So I don't know why it was just in the docs, but we're going to use that to test this algorithm out and see how it works. We're also going to copy in this function to hash a password. And this is bcrypt.gensalt, which generates some salt. And then hashes our password. So bcrypt should, and in TinyApp it is, used asynchronously. In this scenario, we're just testing it out. I'm just giving you a little demo of it, so we're not using it asynchronously, but it should be used asynchronously. We are going to hash our password and then log it back out. So if I say const hashed equals bcrypt hash sync, my plain text password. So I'm grabbing this one here. This is the one that I want to hash. And I'm adding the salt rounds. Salt rounds are basically 2 to the power of this number is how many times the password is going to be encrypted with salt. So this is not just a straight up one-way encryption. It's being encrypted several times. And so right now we're doing 10. Let's console.log my plaintext password and my hashed password. And because we are no longer working in app.js, we're going to go node hashing. Cool. I get my plain text password, which is bacon, and then this string here, which is obviously not bacon. Oh, sorry, that was way too big. If we have a look at this here, this tells us everything we need to know, and this is a handy feature here. The beginning tells us which algorithm it's using, and then here it's telling us how many salt rounds it's using. So what happens if I change the salt rounds, let's say to 5, and we run that again? Cool. What happens if I change it to 15? Takes longer. Yeah, it does take longer because this is, so 2 to the power of this number is how many times it's being encrypted. Let's try 30. It's a while. This is gonna be a real secure password, but not super ideal, is it? Having a user have to wait. This is a long time to log in. So there's a bit of a negotiation here of like what's a good number so that it's as secure as it can be, but also doesn't take up too much time. I think 12 is like a good standard at the moment for encryption. This is still running. This is 2 to the power of 30. It's probably just going to take forever, so I'm going to stop it. But 12 is good. Cool. So we get bacon, we get our hashed password. Okay, so what happens now when a user logs in? How do I compare bacon to this new hash? Well, the hashes are different because of the random salt that gets put in with every hash, right? If we do this again, this is a different string or hash than this one. So how do we compare the two? Calgary, how you doing? Good. Has to be some sort of key. It probably is. It's just that we don't necessarily need to worry about it because we have a bcrypt function. Yeah, exactly. So we can really just get this to handle it no problem without looking at it. A triple equals will not work in this scenario, right? We can't say bacon triple equals this string because it's just not going to work. But what we can do is use bcrypt compare. Compare sync. So we go my plain text password compared to the hashed password. And let's just, I'll comment that out for now. And I want to console.log this. True. Okay, so what's happening here is that bcrypt compare sync is taking in my plain text password. It's taking in this hashed password, and it's verifying that they are the same thing. There's a whole bunch of stuff that's going on behind the scenes that we don't really need to care about because this is working as it should and verifying that we are logged in. If I were to use this same function, but let's use this some other plain text password, which is not bacon. I get, so first one true, second one false. And there we have bcrypt verifying our passwords. Yes, it's decrypting, but it knows, so based on like this here, it knows the salt rounds, it knows this. Behind the scenes, oh, thank you. Can someone just brute force pass random passwords through the hash and compare the hash results if bcrypt adds the algorithm and salt rounds in the found data. So, good question, Greg. In theory, brute force attacks are not impossible, but they're very, very, very unlikely. So, kinda yes, but it would take a heck of a lot of work. And that's why we use bcrypt. There's like, it's not a foolproof method, but it would take a very, very, very long time and a lot of work to be able to like crack that. Brute force. Oh, if you pass random passwords into the form. Yeah, so sorry, yeah, so like a brute force attack that way. Yes. Yeah, like you could potentially do that. But that takes that's the same kind of idea. It's going to take a lot more work to brute force that. Yeah, like in theory there is brute force, but this is the most like secure way of dealing with that because you're always going to have that regardless. So this is the most secure. No probs, Greg. Brit is typing. Dun, dun, dun. Just wait a second. So it is a one-way process. Yes, Britta. It is a one-way process. It gets, it's never actually being, I guess the sense is it's never actually being decrypted in the sense that you're never getting that plain text password back. It's the comparison of like this algorithm and this hashing to this hashed password. So it is one way. In terms of like behind the scenes of how it works, user input. It's worth reading up on this Wikipedia page and also like the encryption reading in today's Compass. Behind the scenes stuff is there's a lot in terms of like algorithms and hashing that you can read up on and how exactly they work. Ultimately, the kind of point of this is that you don't need to know how they work. It's just that they work and you can use them to secure your app and secure your passwords. So let's use that in our app now. We've got our bcrypt. Let's bring that in. So I'm going to bring in bcrypt and salt rounds into our app. And then where we've got our verification. So this is happening in if user.username, blah, blah, blah. Actually, the first thing we want to do, we want to hash our password, right? So when we're logging in, when we make the post to log in, const password equals rec.body.password. We want to hash immediately as we set this variable. And so to do that, and yeah, we've still got access to bcrypt. We're going to import. So we're going to bring in this function. Script.hash. And we're going to set const hashed. And instead of my plain text password, I'm going to use password. Okay, so let's just console log that and see what we get. And nodemon. And instead of login, we're going to go post. Oh no, I broke it. because actually I don't think we need that. Echo submit. We get meow. Okay, that's not what we wanted because we're console logging password, not hashed. Oh, I gotta delete the cookie. Sometimes my cookies don't show up in like my browser window. If this happens, just do a refresh. I think it's something to do with my DevTools. Submit. Cool. And we get our hashed password. Now this is really what we should be doing, is having like a register page. This isn't really like we're logging in and hashing the password, which isn't what we want to do. What we want to do is have a register page. So let's create a register. Because there's no point in hashing a password that's logged in. I mean, we want to compare that password, but we want to hash the password upon registering. So we're going to create a register, and to do that, we need a view for a register. Oh, no, do we? Let's just add that as a form to our index. We're going to have a login and a register just for the purpose. This isn't how I would set it up in my app. But we'll have a register anyway. Register, post, text, username, password, and submit. Okay, so we're going to register. And now let's check that out. Okay, so we got a register and a login. We're going to focus on this register. Instead of obviously like checking the user in the database, we're going to add that. We're going to add that user in. So const username equals rec.body.username. Oh man, it keeps doing that. It's really annoying. And then const password equals, and this is where we're going to hash it. And instead of password, we've got rec.body.password. Whoop. Except not const hashed. It's just going to be password. Okay, and to add it to our user database, we are going to say user db. And for now, I'm just going to assign it a new ID in here. I would probably want to write like a function that would generate some new IDs. But for this purpose, we'll just say user db4 equals, and then what do we have? We've got, so ID for username, fave cookie, we'll just make one up. What's a good cookie? Macaroon, nice. 2 O's or 1? 2. Because like, yeah. There are 2 cookies. There's macaroon. So I think, so macaroons are like the coconut one, the coconut chocolate ones. And then macarons are like the little biscuit with the filling inside. I think, yeah. So, little cookie lesson for y'all. They're really good. They're really fun to make, these ones, because to make them, I don't know if anyone's made them before, you like pipe out little circles on a baking tray and then you just whack it on the table because you have to get the bubbles out and make them all flat. It's really fun. So if you're looking for something therapeutic to do while you're in boot camp, like just whack some cookies on a table. Okay, aside, user db4 equals ID, username, fave cookie, and password equals password. Okay, I want to verify that I'm doing this correct, so I'm just going to console.log the whole user database. DB. Yeah, that's what I want to do. So I'm going to register. I'm going to create a new account. What's a good name? Ella. Ella's here somewhere. I don't know where, but Ella. Ella the dog. And we're going to go woof is our password. Okay. So nothing's happening because we haven't put in a redirect or anything. We haven't, like, aha! There we go. I have added Ella to my database. And I now have this hashed password. And this is how you should be storing passwords, not in plain text, right? So now, and also I want to redirect as well. Res.redirect. Just back to the home page. Console user DB, that's fine. Now we need to add some verification in. So in our login, we get in a password, and we need to compare this against the password that we have in the database. But what we're not going to do is like pipe this through this algorithm again, because we're going to get a different hash. We're going to use our comparison. So first things first, and actually we can do this in the logged in user. We're going to replace this verification. And so we have our user. And so user password is going to give us the password we want to compare to. And then we're going to compare password. So our algorithm for that is compare sync. So really we're working with bcrypt, you're really just working with these two functions. You've got hash sync, which hashes the password, and compare sync, which compares the two. So compare sync, and we'll just console log it for now to verify. Let's say, so what are we comparing? We've got the one that we're getting in, which is what we've stored as password, and then the user password. So your first argument is the plain text that you're getting in. Let's console log that and check it out. And we have to register again because every time I restart the app, we don't have a database that's storing this information. Let's go Ella and woof. So submit. And now when we try to log in as Ella with woof, dun, dun, dun. Data and hash arguments required. Awesome. Oh, it's freaking out. Okay. At object.compareSync, data and hash arguments required. Interesting. Let's console log these both out and see what we're getting. So we're just going to go through that process again, do a quick register. And now, not logged in. Down here. Ooh, woof, undefined. Okay, awesome. So that's because I have got this wrong. Let's console log user, see what we get. Not logged in. Maybe if we just do user.password. Because it looks like we're getting the right object. Oh, maybe. Oh, hang on. Yeah, what are we getting here? User DB. Let's check that out. You might be onto something. Not logged in. Okay, that's, yeah, so user.password. So now in theory, register again. Submit. True. It's working now. It should be good. Yeah, so we get this true here, which, that was a good, that would have been my, like, next debugging. So the suggestion was try switching the arguments around. We're getting true back, which is what we want. Finally. So I think the falses are from before, but let's test that out with some more room in here, just so that we can, actually, let's just restart and do that again to make sure doubly that it's working. But yeah, that's a really good suggestion. I was kind of guessing that that's the order they were in. And so my next thing would be, let's check the documentation like a good developer and make sure that I'm not putting them in the right order, or that I am putting them in the right order. Not logged in, which is fine, because we're not doing anything with this yet. We're just getting the true back. So I'm gonna now say if bcrypt, and I'm gonna take out this console log because we don't need it. If this is true, so if we are verifying this, then logged in user equals user. And then we're gonna break, just like we did before. So that's all we're really doing, is just we're replacing this verification of like testing our plain text with this compare sync. Let's make sure it works. Ta-da! And now we've secured our app, and we're not storing passwords in plain text. Y'all look happy. That makes me happy. Okay. Calgary, Vancouver, any questions on any of that we've covered so far? Yeah, go for it. That's a really good question. So for Calgary, would you do the hashing on the client or the server? I want to say the server, but let's have a little Google. Yeah, that's a really good point. Like, so to protect man-in-the-middle attacks. Client-side hashing. Interesting. So client-side hashing is uncommon, but a good practice. So I think you're right there, where like as soon as you're getting that plain text password in, it would be good practice to hash it. But uncommon, I think, and that's generally what I've seen, is when I see passwords getting hashed, I've only really seen it on the server side. So yeah, so if you're using HTTPS already, it's probably not a big deal. The other thing is, like, this is how, you know, we're storing passwords right now in TinyApp. The alternative to this, and honestly a good idea is to use something like Auth0. Auth0 is a way of completely not having to deal with any of this login yourself. You're using a tool that is already created, it does all the hashing, you don't need to worry about it. That's like the next step. So today we've gone from like sending a user ID in our parameters to storing user ID in cookies, to encrypting cookies, and then to storing passwords and hashing them. And then to make your life even easier, I would check out something like Auth0. That's not something to worry about right now. That's just something to bear in mind. When you're out of bootcamp and you're in your new dev jobs, it is likely that your company may be using something like Auth0 for user verification. At my company, we wrote a user service to handle verification, like authentication and authorization, like ourselves. And honestly, it was the biggest headache. And my boss at the end was like, yeah, that was a mistake. Like, we should have been using Auth0 all along, just because it adds in like a big layer of security that you're having to be accountable for. And if you can offload that to something else, do. Because these tools are created specifically for this purpose, so why not use them? Yeah, it's my little password rant. Calgary, any last questions, or can I get a no if you're all good? Oh, they also, yeah, check out the reading. Bcrypt is a really good standard, but there are others. It's not the only one. All good, awesome. Cool, thanks Calgary. Have an awesome day. And thanks Vancouver. Also have an awesome day. All right.